Okay, so just really quickly I want to talk to you about how we can solve with factoring. This is another method in our quadratic solving toolbox. Okay, the first one we talked about was graphing, and we talked about looking at where the equation crossed the y-axis, where the equation crossed the x-axis. So now we're going to start talking about factoring, which is a little bit different. And we're going to kind of reference this hand model to help us keep track of all the different pieces that go into factoring. Okay, so there's 5 steps. The first step is looking for a one-term piece. You're looking for, is there a greatest common factor? If there's a number of variable or both, or a product of numbers and variables that we can pull out of our expression, out of our equation, we want to pull that out. That's called the greatest common factor. The next one is when we have 2 terms, right? Thumb and pointer finger, 2 fingers, 2 terms. We're looking to see if it's a difference of squares. Okay. Third one, we're going to use our FOIL factoring. When I say factor, this is what most of you think of. Okay. Then the fourth one, we're going to look for groups. Now, we are not going to tackle that one right now. We're going to save that for chapter 6. But then the 5th final pinky, the pinky question you have to ask yourself is, did I miss anything? Okay, so it's a series of questions just like your hand. Okay? Your thumb is that big, ginormous GCF. Is there something I can pull totally out of it? Just like your thumb, you can pull it almost away from all those other fingers. 2 is difference of squares. 3 fingers. That middle finger is your FOIL factor. 4th one is factoring by groups. And then the very last one, did I miss anything? Okay, because if you miss something, you're going to have to make sure that we can catch it then so we don't miss anything. The goal is to not miss anything. Now, as we're looking at this, we're going to look at each one a little bit more in depth. So let's talk about some of those first 3 a little bit more in depth. What is the greatest common factor? Well, the greatest common factor is a number, a variable, or a product of a number and a variable that evenly divides into each term of your expression or of your equation. We're looking for a number, variable, or product. Variable is not a word. A number, a variable, or a product that we can pull out. And we can pull it out because it evenly divides into every term in what we're looking at. Let's look at an example. (6x squared minus 3x). Is there a number that I can pull out of 6 and 3? Yeah, they're both divisible by 3, so I can pull a 3 out to the front. Is there a variable I can pull out? Yeah, they both terms have an x, right? Because x squared is x and x. And 6 is actually 3 and 2, and that's where we get that 3 from. So each one here has a 3 and an x. So we pull a 3x out to the front. When we do that, right here, in the first term, we are left with a 2 and an x. 2x. In the second one, we need a placeholder. And so what we do, if we are going to pull something totally away, right? If we're going to totally clear the crap and pull it all the way out, we need to replace it with a 1. Now here I put a -1 because it was a minus 3x. So that 1 serves as its placeholder. We are doing the distributive property in reverse. Okay? The next one's called difference of squares. This is our 2 finger. Remember? This is the thumb. Thumb it. Okay? Difference of squares, that means 2 fingers. We're thinking on our pointer finger here. Okay? So with that difference of squares pointer finger, what we have here is we have something that looks like a squared minus b squared. Both of these things here are perfect squares. X squared is a perfect square. 4x squared is a perfect square. But they're perfect squares. Both of them. And this factors into 2 binomials. A plus b and a minus b. Okay? When we do this, if we were going to go through and FOIL that, the AB's would cancel from the O and the I. Okay? And so what we would have here is that returning, or that beginning, a squared plus b squared. So it's like we think in terms of the square root. Now let's look at an example. Trying to give you lots of good examples to think about here. I hope you're writing them down. 9x squared minus 16. Is that a perfect square minus a perfect square? Yeah, it actually is. 9x squared is actually 3x times 3x. All of you should know right now that 16 is 4 times 4. So when we split it, we're looking at the square root and the square root. So I'm going to do the square root of the first one. Well, that's 3x, because the square root of 9 is 3, and the square root of x squared is x. Same thing for the second one. I'm going to put that 3x in there. And then I'm going to do the plus 4 from the square root of 16, and the minus 4 from the square root of 16. So plus 4 minus 4. So that is the difference of squares. We split them up based on what the square root is. And then FOIL factors. This is our middle finger. If you're thinking FOIL factors, you're thinking about your middle finger. And normally I would not tell you to use your middle finger, but you're actually going to use your middle finger a lot. Just not at people, just at your math homework, right? Okay, some of you already do that. So your FOIL factors. Your FOIL factors, you're going to use that idea of FOIL. And what you're doing is you're splitting a 3-term thing into 2 binomials. Binomial meaning 2. Okay, we technically haven't covered this language, but I know you know it. Binomial meaning 2. Okay? When we have something like this, we have something like that. We can actually do something called FOIL, first times first, x squared. Outside times outside, negative 6x. Okay, this one I don't like. I'm going to change it really quick, because otherwise it's a difference of squares, and I want this one to be different. Boo. Inside times inside, 5 times x is 5x, and last times last is negative 30. Okay? And when we combine our like terms here, we're going to get negative x. So when we see something that looks like this, what we're really looking at here is the result of doing FOIL. And so now we're going to unfoil. The way this is a result of doing FOIL is this is from that last piece. This is from the OI. You got to OI it to make the middle. Okay? So let's look at an example, because I think that's going to make this easier. To be honest, FOIL factoring is difficult until you start looking at examples and practicing and getting good at numbers. Here's an example. So somehow, my first times first, my outside times outside, my inside times inside, they made this. Now this right here, this is from the first times the first. So what's the only way I can multiply to make an x squared? Well, that's got to be x and x. As we get to more complex ones, then that's going to change a little bit. But for right now, it's x and x. Now we know that 30, that C, that final piece right here, we've already talked about what A, B, and C are. That comes from the last times the last. Okay, so x squared's from here. And then right there, we're going to have a last times the last. Now, these two could either be positive times positive to make a positive 30, or negative times negative. I'm not going to worry about that right now. I'm just going to start thinking about what two numbers will multiply to make 30. Well, I could say, okay, Ms. Vista, 1 and 30, 2 and 15, 3 and 10, and over here, 6 and 5. That's great. Those are some great choices. And we could start plopping numbers into spots and try and guess and check. Because this is kind of a pick and pray. You have to just start guessing, unless you know kind of a pattern. That OI term, that B, that negative 11, we need two numbers that multiply to make 30, And when we combine like terms in that OI part, they make a negative 11. Okay, I'm going to give you a hint. 1 and 31 aren't ever going to give 11. 2 and 15 aren't ever going to give 11. 3 and 10 maybe, but you should be able to say in your mind, no, 3 and 10, even if they're both positive, positive 13 for that OI. If they're both negative, negative 13 for that OI. Okay? Really, we should start to say, okay, I want 6 and 5. I want 6 and 5, and of that 6 and 5, I know that when I combine them, this 6x from the inside and the 5x from the outside, well, they need to both be negative to make a negative 11x. FOIL factoring is probably the toughest one. Okay? It's going to be the toughest, but it's also going to be the one that you're going to get the most good at. The goodest. Nah. Okay? It's the one you're going to do the best at. So let's actually look at a couple examples here real quick. Some real quick examples. Here's your first one. X squared plus 15x plus 56. X squared minus 49. Oh, I love that difference of squares happen here. 2 terms. You're on your pointer finger. You got 2 fingers out at that step. 6x squared plus 13x plus 6. 4x squared plus, just kidding, minus 8x plus 4. And x to the third minus 3. Nope. X to the third minus x. Okay? So right here we're going to look at a couple examples. I want you to try them. Just give me your best effort with what you know right now and see what you can come up with. And in a second here we're going to check them. Really quickly check your first two. How did you do? Hopefully in the first one you go, yep, I got my x's placed down because I know that x and x is how I'm going to make my x squared. Then you go, okay, what's going to make a 56 when I multiply, but a 15 when I collect my like terms? In the second one, difference of squares. Hopefully you nailed that. Let's go to the third one. I need 2 numbers that multiply to make 6 here. I don't have a GCF. You know what? I should even back up. Not a GCF. No thumb. Okay? Then 2 terms. So I'm going to add my pointer finger. 2 terms? No. Okay, now I'm at the trinomial. Now I'm at FOIL factoring. Now I'm stuck in my middle finger running through the steps in my mind. And so we got 1 and 6 and 3 and 2, but we also can't just throw in x and x because now we also have 1 and 6, x, and 3 and 2, x. And so now we have a lot of choices. What's nice for us here is everything is pluses, and so we know we're going to have pluses. Okay. My hint to you, a hint for you. This is a hint. Start with the ones in the middle. So I'm going to start with 3x here and 2x because it's more likely that your book is picking something in the middle. Which means I'm going to start with 3 and 2 here too. There's my guesses. I need to check it. I know based on what I picked that if I do FOIL first times first and last times last, they're going to fit the criteria. I got to check the OI. 3 and 2, that's 6x squared. And 3 and 2, that's 6. We got that part right. We said we were good there. So now we're going to check the OI. 3 and 2, that's 6x. That's 6x. Well, that did not work because that only makes 13, or that only makes 12, and I'm supposed to get to 13. Well, crap. Okay? I'm going to switch the numbers. I don't like the numbers, so I'm going to switch the numbers. I'm going to make this the plus 2 and this the plus 3. Inside, inside, outside, outside. 4x, 9x. Did I get 13x? We did, and we are happy. That's tough. That's what we're going to practice. Okay, so we're going to be practicing this. Let's check those last two. Did you find the GCF in both of those last two? In the first one, it was a 4. And then in the second one, it was an x. And when we got here, we said, are we finished? No, we are not finished, Miss Vista. We got work to do. No, we are not finished. I got difference of squares. I got work. I'm going to put in some work on this problem. Okay? So, this is factoring. And we're going to take some time and talk about factoring. Tomorrow, when we talk in class, we're going to get a little bit more into what's called the zero product property that changes these and helps you turn the factored form into actual solutions. So that's what we're going to talk about in class tomorrow.